Hi, I'm Chris with Sanderson Test Prep, and in this video we're going to introduce antiderivatives. So when you first learned some of the rules for derivatives after learning the definition, you probably learned power rule, product rule, quotient rule, chain rule, etc. And here we're going to start with power rule, and we're going to see how we can walk in the reverse direction and find the antiderivative of a function. So let's review power rule. When you originally saw power rule, you saw that you had an original function, and then to find the corresponding derivative, you went in this order. First, you multiplied the exponent times the coefficient. So in this case, 2 times 3 would give you 6. And then next step, you subtracted 1 from the exponent. So 2 minus 1 gave you an exponent of 1. Even though we don't have to write it in, there's an exponent of 1 here on that x. So that's how we can go from the original function to the derivative function of f prime of x equals 6x. Now when you're finding what we call the antiderivative, or a term that you're going to start getting introduced to is integral, which means you're going in the reverse direction of finding the derivative. So if you're going in the reverse direction, we're basically going to take the same power rule, but we're going to evaluate it in reverse. And these functions are going to flip both in terms of the order that you apply the multiplication and subtraction. You're going to switch the order, and you're going to switch the operation. So here, instead of subtracting, we are first going to add. So that means if we have 6x to the first, when we're going in the reverse direction, so here, as we go in the reverse direction, first you're going to add 1 to the exponent. So that would give us 6x squared. And then you're going to divide by your new exponent. So when you divide by 2, 6x squared reduces to, over 2 reduces to 3x squared. So you can see that this reduces to give you 3x squared. So just like we see in power rule for finding derivatives, you multiply first, then subtract. When you're finding the antiderivative, you're going to flip that around. You're going to add first to the exponent and then divide by that new exponent. And so that allows us to interchange between our original function and our derivative function, or go in the reverse direction and take a derivative function and find the corresponding antiderivative or integral. So let's take a look at a couple examples, and I want to introduce a notation that we might not have seen, which is this is our integral symbol that we see here. And when we see an integral, it's basically the symbol that is asking us to find the corresponding antiderivative. So to find the antiderivative for this, let's see what we would get. So let's follow those two steps. We're going to add 1 to the exponent. This would be 4x cubed. And then we're going to divide by that value. And that's going to be 4 over 3x cubed. So that would be the antiderivative of 4x cubed. Now with integrals, we do have one other thing to write in, and that's going to be plus c. And the reason we write that is because we don't know, when we're calculating an integral, we don't know whether or not that original function had a constant there or not. Because as we may remember, so for example, if you had a derivative function, let's say this was 4x squared plus 7, when you take the derivative, this would be just 8x. And so we're never sure whether or not, when we're going in this direction from derivative to the corresponding function, when we're taking the antiderivative, we don't know whether or not this constant existed, because the derivative here would be the same if you were taking the derivative of 4x without the plus 4x squared, sorry, without the plus 7, or with the plus 7. So since we don't know whether or not that constant is there, we represent our integral as being our antiderivative and then plus c. So we're adding in the possible constant that could have been there in the original function. So it's a really good habit as you're starting to get introduced to integration to just get in a habit. Whenever you take the integral, make sure that you write plus c at the end of that antiderivative that you form. Let's try one more example with a slightly longer, more complex looking polynomial, but we're still going to do the same process of walking through power rule in reverse. So here we'll have 5x add 1 to the exponent, divide by that new exponent. 3x, we're going to add 1 to that exponent, divide by that new exponent, minus 7x, add 1 to the exponent, divide by that new exponent, plus 2. And in this case, this is sometimes tricky for people at first, so I'm going to write it in here a little bit differently, but when we go to add 1 to the exponent, so what exponent do we have on our x value here for the constant 2? Because we don't really see an x value. But remember, anything to the 0 power is 1. So when you see a constant, you can treat it like 2 times x to the 0 power. And that sometimes when you're first learning how to take antiderivatives makes it a little bit easier to apply that same approach with power rules. So here we have 2x to the first divided by that exponent. And remember, what do we always do with an integral? At the end, we're going to write plus c for the possibility of there being a constant in that original function. So now let's take a look at how we can simplify this. A lot of things here are going to cancel out or simplify. So this would be written as x to the 5th plus x cubed minus 7x squared over 2 plus 2x plus c. And if you are comfortable taking derivatives, the nice thing about learning antiderivatives is you can always double check your work. So when you figure out what your answer is, if you need to, you can walk backwards through taking the derivative like we have done previously, and you can say here, okay, well, x to the 5th, if I were to derive it, that's going to be 5x to the 4th, plus derive this term, that's 3x squared, minus derive this term, that's 7x, plus derive this term, that's 2. And so you can double check to make sure that the antiderivative that you calculated is in fact correct by taking its derivative and making sure it matches the function that you were asked about to begin with. For more, please check out our other videos on more complex versions of antiderivatives and integrals. Thanks for watching.